Hey everyone, on this video we're going to be looking at another algebra topic. This is solving linear equations. So these notes will be in the back of your test 1 lecture notes. It should be 2 pages. So first we need to just talk about what an equation is. So an equation, you're going to see that equal sign. And it's basically telling you that whatever is on the left side and whatever's on the right side have to represent the same value. And then a solution to the equation would be a value that when you put it in, it makes the equation true. So if we look at this first example, I'm going to cover up this 8 for a minute. We have x plus 6 equals 11. So what we're saying is x plus 6 has to have the same value as 11. Now this one's pretty nice. We can see that the only value that would make that true would be to make x 5. So we know that 5 plus 6 would be 11. So 5 would be a solution. Now it's not always this obvious. So if you're just given an equation and a solution and we're asked to determine, is this number a solution to this equation? We already know it's not because we know the only value is 5. But what we can do is we can take that 8 and we can just plug it in, substitute it in place of x. So if we say 8 plus 6 equals 11, we get 14 equals 11, which is clearly false. All right, so the answer to this would be no. 8 is definitely not a solution to the equation. So for number 2, we have to be a little bit careful here because we have a negative 6. So our equation is 10 minus y equals 16. So when we plug in that negative 6, we have to be careful. We have a 10 minus, and then in place of y, we're going to put negative 6. So you have to get that substitution, right? So whatever was there for y, you're going to replace it with negative 6, but we have to be careful not to lose that minus sign. So we know from our integer operations that if we minus a negative, that makes a plus. So that makes 10 plus 6 equals 16. And we get 16 equals 16. And that one is true. So that one checks out. So that means that negative 6 is, in fact, a solution to that equation. All right, so for our last one, this one's a little different. We have negative 3x. So this means negative 3 times x. That is a multiplication there. So negative 3 times x minus 9 equals 3. So we're going to keep the negative 3, and since we're multiplying, we're going to use parentheses for multiplication. We're going to replace that negative 4. So once again, we're seeing that substitution. In place of x, we're putting that negative 4. It's really important to keep the parentheses so that you know you're multiplying and not adding or subtracting. So we'll bring down the rest of the equation. Now remember, a negative times a negative is a positive. So I get 12 minus 9 equals 3. Kind of out of room, but I get 3 equals 3. That gives me a true statement, so I know that this one is also a solution. So that would be a yes. All right, so now we're going to look at actually solving some equations. So when we're solving equations, one useful tool to have is what's called the addition principle. It says for any real numbers a and b, a equals b is equivalent to a plus c equals b plus c. So if we translate that, what they're saying is if we start with two things that are equal, if we add something to one side, it's fine as long as we add it to another side. Okay, so think of it as kind of a balanced scale. Whatever you put on one side, you've got to put the same thing on the other side to keep it balanced. So we're going to reword this to say you may add, and I'm going to put in parentheses, or subtract any number but you must add, and again, or subtract it to both sides of the equation. So the reason I put subtract in there is we learned when we did integers that subtracting is the same as adding the opposite. So adding and subtracting, we can do either one. So sometimes I hear this called the equal actions principle. Basically, whatever you do to one side of the equation, you have to do the same to the other. So let's start with this equation. We've already seen this one once. This one is simple, and we know the answer's 5 just by looking at it. But just to go through the process, what we'd like to do is get x by itself. So since we have x plus 6, I know that if I subtract 6, the positive 6 and the negative 6 are going to go away. So if I subtract 6 from this side, I must also subtract it from this side. So if I look at what that gives me, it's actually giving me x plus 0, right? Because that's what we get when we add a number to its opposite, equals 5. Now generally we skip this step. We don't show the 0. We get x equals 5. All right, so we've got that one solved. We can plug it back in and check it and see that it gives us a true statement. So for number 5, we have x minus 3 equals negative 5. So I want to get x by itself. I want to get rid of that minus 3. So to make it be 0, I need to add 3. So notice we're always doing the opposite sign here. If I add it to one side, I have to add it to the other. I end up with x plus 0. Here are your integer rules. I have to subtract since the signs are different, keep the sign of the larger number, and I get x equals negative 2. If you want to do a check, you can always go back and take that number and plug it in for x. That would be negative 2 minus 3 equals negative 5. On the left, the signs are the same, so we add and keep the sign, and we can just verify that that gives us a true statement. All right, so here's our last one for addition principle. I have a plus 13. So to get rid of that, I need to minus 13. And so we generally don't do the 0 step. A lot of times we just do this. We know that those 0 out, and we get y equals. These signs are the same, so I add and keep the sign, and I get y equals negative 15. All right, so that's your addition principle, or addition and subtraction principle. We also have one for multiplication. It says for any real numbers, a, b, and c, as long as c isn't 0, a times b is equivalent to a times c equals b times c. So what this says is you may multiply or divide any number except 0 to both sides of the equation. So we do have to leave out 0 in this case. Can't divide by 0, that's not defined. Multiplying by 0 gives you 0 on either side. Now notice I include division. Dividing is the same as multiplying by the reciprocal, where you flip the number over. And so we can do multiplication or division with this rule. All right, I also have something listed here. If you have a product like 4x, that means 4 times x. We call the number in the front the coefficient. So in this case, 4 is the coefficient. So if I look at number 7, this is negative 7 times x. So I'm not really seeing that multiplication, but it is there, and that equals 42. So what a lot of people want to do here is they want to try to add 7. That's not going to help me because I've got the x multiplied there. So I'm thinking if I'm multiplying, to make this go away, I need to use division. So I'm going to divide both sides by the coefficient. And remember, negative 7 divided by negative 7 would give me a 1. So I get 1 times x equals negative 6 when I do my division. So I get x equals negative 6. So on the problems up here, we were trying to get a 0, because that's what we call the additive identity. If you add 0 to something, it doesn't change your number. But here we're trying to get a 1 because 1 is our multiplicative identity. If I multiply a number by 1, I don't change the number. Okay, so a little bit of a different goal here. So if we look at number 8 to get x by itself, I do need to use division. Okay, that's going to give me 1 times x when I do 6 divided by 6. 84 divided by 6 gives me 14. And I get x equals 14. Okay, so our last one on this row is -4 times y. So I'm multiplying. To get rid of multiplication, I use division. Notice I am taking the negative because -4 divided by -4 gives me +1 times y. And then here a negative divided by a negative is a positive. So I get y equals 5. So these first three were very similar because all I did is divide by the coefficient. If I look at number 10, -x equals 15, this is really a coefficient of -1. So I don't see the 1, but that's -1 times x equals 15. So if I divide by the coefficient, that's going to give me a 1, and I'm going to get x equals -15. All right, now the last two are a little bit trickier. So if I have x over 3, that means x divided by 3. So since I'm doing division, to sort of undo that, I want to use multiplication. So on this one, I'm going to take my equation and I'm going to multiply both sides by 3. So technically this 3 here, this is 3 over 1. So I can cancel the 3's and I end up with x over 1, which is just x. And then I do my multiplication and I get -12. Okay, so here I'm using multiplication instead of division. So let's look at this one. I have -1/4 x equals 20. So let me write that down here. So here what I'd like to do is I'd like to multiply by the reciprocal. So if I have -1 over 4, the reciprocal would be -4 over 1. So remember the reciprocal, let's see if I can spell that, is just taking the fraction and flipping it over. So -4 over 1 is just -4. So I'm going to multiply both sides by -4. And if you want to leave it as -4 over 1, that can be helpful. So notice that the 4's cancel, and a negative times a negative is a positive, so that still just leaves me with a +1. And then 20 times -4 is -80, so I get an answer of x equals -80.